In this video, we will see how to adjust the target difficulty. Target difficulty controls the block mine time. In Bitcoin, the target difficulty is adjusted after every 2016 blocks, which is approximately 2 weeks. In Bitcoin, the average block mine time is 10 minutes. So let's understand what is this target difficulty. Target difficulty is just a number. Let's say this one random number. In order to mine the block successfully, miner has to find a solution or the number that is less than this number. We have already implemented this functionality inside the block header class. So right here, so we can just change the nonce value to generate a new number, and then we will compare that number against the target. If the number is less than target, that means we have successfully mined the block. Now we will see how to adjust the target difficulty. Now you may ask, why do I need to adjust the target difficulty at all? Let's understand this with an example. For example, I am a miner and I mine a block, and for solving the cryptographical puzzle, I'll get 15 bitcoins as a reward. Now let's say there is another miner in the network who has deployed high computational machines that can mine the block in less than 10 minutes. Now to keep the balance in the network itself will check if the approximate block mine time is 10 minutes or not. If the block mine time is less than 10 minutes, it will change this number and it will make it more difficult for the miners to mine the block in less than 10 minutes. Now, if it is taking more than 10 minutes, then again it will change the number so that your average block mine time should always stay approximately 10 minutes. Let's see how to recalculate the target. I have block number 0 to block number 16. We will recalculate the target after 2016 blocks. Let's say block number 1 took 10 minutes to mine, block number 2 took 8 minutes to mine, and so on. Now we will add up the complete time all the way to block number 16, and then we will divide that time by 2016 into 10. 2016 is the number of blocks and 10 minutes is the expected time to mine each and every block. Now if this number is greater than 1, that means we will multiply that number with the target and it will increase the target. So if it is greater than 1, that means we took more than 10 minutes to mine the block. And by doing so, we are making it little bit easier for the miner to mine the block within 10 minutes. Now, if this number is less than 1, that means this target will be reduced to some number and it will make it little difficult for the miner so that the average block mine time should always stay 10 minutes. And that's how you recalculate the target. Higher the target value, easier it is to find the solution. Lower the target value, it is difficult to find the solution. Now, if I'll ask you to throw a stone in this circle, and you may first throw the stone here, so you may require a lot of attempts to get the right one so that your stone will directly go in this circle. So this is what the lower target means. Now, if I'll ask you to throw the stone in this circle, you may first throw it here, maybe here or here, but in very less number of attempts, you will get it right and you will throw the stone inside the circle because the target is bigger and it's very easy for you to throw a stone inside this circle. And that's exactly what is the lower target and higher target means in Bitcoin. Higher the target, easy it is to find the solution. Lower the target, it is difficult to find the solution. When the target is lower, you have to generate many more hashes as compared to when the target is high. Now let's implement the functionality. I'll copy and paste few constant values that we need to calculate the target. First one is max target. I will explain why that is required. And then we have the average block mine time, which is 20 seconds in our case instead of 10 minutes. And then the target difficulty period, which is 10 blocks in our case instead of 2016. And then we have the average block mine time, which is 20 into 10. And now let's implement the functionality here. Create a function here, define adjust target difficulty self, and it will take height as an input, block height. We will check if block height n, because we want to adjust the target difficulty after 10 blocks only. And then we will create one more function here. So for now, let's call the function self dot get target difficulty and timestamp, and pass block height. And now let's create this function. Define self, and it will take block height as an input, block height, and by default set it to none. If block height, if we have the block height, then we will read the data from the blockchain. Blocks equals to blockchain db, and read all the blocks, and then we can do blocks block height, for which block we want to get the value, and then from block headers we'll get the bits, because bits is the target difficulty that we would require. Assign it to bits, and we also need the timestamp. I'll copy and paste this and change bits to timestamp. And else, if we don't have the block height, then we can read the last block from the blockchain db, last block and now we can do bits equals to block, then block header, and bits. I'll copy and paste the same thing here as well and change it to timestamp. This will give us the timestamp of the last block, timestamp. And now let's return bits comma timestamp. Now here we can receive bits comma timestamp. We need to call this function one more time and also do -10 here, and we can call it last bits comma last timestamp. Call the same function, get target difficulty, and this time don't pass anything. So we need to call this function twice. First is, let's take an example. For example, we have block number 0 to 9. We want to adjust the target difficulty after every 10 blocks. From 0 to 9 is 10 blocks. So first we will read the 9th block here, and then we will also get the 0th block. So this will give us the 9th block, which is the last block, and this will give us the 0th block. And now we can calculate the target here. So we need to import one function, bits to target. So let's import it right here, bits to target, and pass the value in the byte format, bytes from hex, and pass the bits value that we have received, and this will give us the last target. And now we can calculate the average block time. Average block mine time equals to last timestamp minus the timestamp. So this will give us the total time, and now we can calculate the time ratio. Now that we have the average block time, average block mine time divided by average mine time, which is the constant value. Now let's calculate the new target. New target equals to target into time ratio, and if in case the value is in float, we should convert it to integer, and we can also format it to this to integer. So this will give us the value in the correct format, in numeric format. Now we have the new target. Now we can check if new target value that we are calculating, if it is greater than the maximum target. We should set the maximum target because we cannot set an infinitely large value. So if it is greater than this number, then the new target should be max target. This is the maximum target value. We cannot have target value greater than this. And then finally we can do self.bits equals to target to bits and pass new target here, and self.current target equals to new target. And that's all we need. Now let's call this function. Right before the mine function, we can call it here self dot and pass the block height. All right, so I have started the mining. So now it should automatically adjust the target difficulty. Right now we are at the block number 1559, and let's see if we have the change in the target difficulty. For the block number 1560, we have this difficulty right here, 46E. And let's see what was the difficulty for the 59. And this was the difficulty for the block number 59. So perfect. So it worked. So it should change the target difficulty after every 10 blocks based on if it's taking more than 20 seconds to mine the block or less than 20 seconds to mine the block. One more thing we have to take care is, what if I'll shut down the node right now? And if I'll restart the node, it will again assign the target difficulty to the initial target, which is this target right here. But we don't want to change the target in between. We want to change the target only after 10 blocks. Now let's take care of that. Now I'll create one more function here. Set target while booting self. And I will call this function self.get target difficulty. So this will give us the last block, and we won't pass any block here. So bits comma timestamp. Now we have bits here, so I can do self.bits equals to bytes from x. This will convert the value in bytes, and then we can do self.current target equals to, then we'll set bits to target. So this will convert the value in the numeric format, self.bits. And that's all we need. And now we can call this function where we are starting the node. Here we are creating the blockchain instance. We can do blockchain dot set target while booting, and that's it. It will set the target, and that's all we need. So when we'll start up the node, it will take care of the target, and after every 10 blocks, it will adjust the target difficulty. We can test it one last time. So start the node, and meanwhile let me start the front end as well. And right now we are at the block number 1612. So it should have the same target for the block number 1613 as well. So let's see the target value for the block number 1612. It is FFF001F. And let's see the value for 1613. I think it is still in progress. All right, so we have the block number 1613. Let's see the value, and it has the same value. If you want to learn how to create your very own blockchain just like this one from scratch, then go ahead and check out my advanced blockchain course. In this course, you will learn how to create your very own blockchain from scratch just like this one. If you have liked this video, let me know in the comment section below if you would like to see more short videos like this one.